Imagine a missile that can fly faster than Mach 5, dodge defenses, and, if a state chooses, carry a nuclear warhead. Today, we'll explain how hypersonic weapons work, who already has them, why they break current defenses, and what the world is building to fight back. Stay till the end. There's a surprising weakness. Hypersonic simply means very fast, usually defined as Mach 5 and above. But in military context, hypersonic weapons are special because they combine extreme speed with atmospheric flight and often maneuverability, which makes them harder to predict and intercept. There are two main families: boost glide vehicles, HGVS, and air-breathing hypersonic cruise missiles. Boost glide. A rocket lifts a glider above the atmosphere or to very high speed. The glider then re-enters the atmosphere and glides at hypersonic speed, maneuvering unpredictably. The glider itself usually has no continuous engine. It's the aerodynamic shape, thermal protection, and control surfaces that matter. Air-breathing, scramjet cruise, uses a supersonic combustion ramjet that breathes atmospheric oxygen. Therefore, it can sustain hypersonic cruise within the atmosphere. But scramjets need a very high initial speed, or booster, to start. Russia, public tests and claimed deployments. Kinzhal, air-launched ballistic hypersonic. Avangard, boost glide, ICBM, launched HGV, claimed nuclear-capable. Zircon, hypersonic cruise. Recent exercises show ongoing launches in development. China, DF-17, boost glide delivery vehicle, and DFZF test program. China has repeatedly tested boost glide vehicles and hypersonic cruise concepts. United States, many test programs, X-51, HAWC, HGV research. U.S. programs emphasize conventional payloads for many designs, with active R&D on both boost glide and air-breathing cruise. India, North Korea, and a few nations claim tests or development. Many NATO countries and Japan/France are funding research and countermeasure work. Summary lists of countries involved are tracked by public defense analyses. Can hypersonics carry nuclear warheads? Short answer, yes, in principle. Some programs, notably Russia's Avangard, were promoted as capable of carrying nuclear payloads. Some air-launched systems, like Kinzhal, have been claimed by Russia to be dual-capable. However, many U.S. programs have focused on conventional payloads. The nuclear question matters because a nuclear-capable hypersonic weapon lowers decision times and complicates deterrence dynamics. Three technical reasons explain why hypersonics are so worrying for defenders. Speed-altitude profile. Hypersonic weapons fly at high speeds inside the atmosphere and sometimes on depressed/suborbital trajectories that are different from classic ballistic arcs. This reduces warning time and complicates tracking. Maneuverability. Boost glide vehicles can alter their path during glide. Air-breathing missiles can change heading while cruising. That makes predicted intercept windows small. Thermal and sensor environment. At Mach 5+, plasma, heating, and ionization around the vehicle can reduce radar/IR sensor effectiveness and make discrimination and tracking harder. Advanced materials and high-temperature control surfaces help the missile survive. They also complicate sensor signatures. Put together, these mean traditional layered ballistic missile defenses designed to track and intercept predictable ballistic trajectories face real technical challenges. But important caveat, hypersonics are not magic invulnerable weapons. They introduce new trade-offs, range versus speed, payload versus thermal, protection, and are expensive and technically demanding. States are approaching hypersonic defense on multiple fronts: detection, tracking, intercept, and diplomacy. Improved sensors and tracking. Space-based infrared sensors, persistent overhead ISR, and multi-static radar nets to detect launch plumes and track high-speed maneuvering objects. Early warning still matters. More eyes over the horizon reduce the reaction time problem. Layered interceptors and new interceptors, existing systems, Aegis, THAAD, Patriot, were designed for ballistic or subsonic cruise threats. Some have demonstrated limited success against certain high-speed targets. Major projects aim to field new interceptors and directed energy concepts. The U.S. Pentagon recently launched large procurement efforts, AE Golden Dome/Shield scale programs, to create layered homeland defenses that include hypersonic countermeasures. Hypersonics change the timeline of conflict. Faster strike options compress decision cycles. Leaders have less time to interpret intent and choose responses. That increases risk of miscalculation, especially if weapons are dual-capable, conventional and nuclear. They also make high-value mobile assets, carriers, bunkers, command nodes, comparatively more vulnerable, which can shift doctrine toward dispersal, mobility, and passive defenses. Conclusion: hypersonic missiles are a real technical leap, not invincible, but disruptive. The race is now about sensors, materials, and systems integration. If you liked this deep dive, like, subscribe, and tell me in the comments, would you want a dedicated video on scramjet thermodynamics or on interceptor design next?